Now that we've talked about how I is defined, we're going to start to see how it comes up in the problems that we've been doing. So here in exercise 3, we have a set of incomplete quadratics. The first one is 5x squared plus 8 minus 12. There is no x term. So that means I can isolate my x squared. And when I get that done, I see that I have x squared equals a negative 4. Now previously, I would have to say that this has no real solutions, because when I take the square root of negative 4, that's not something I can do in the real number system. But now that we know about I, we can solve this. Now we're taking a square root, right, to get an answer for a quadratic, so we need to think about the positive and the negative answer. So square root of negative 4 is 2i. So looking at the next one, the first thing I would do is subtract 20 and then multiply by 1/2. Multiply by 2. So we're going to subtract 20. We get 1/2 x squared equals negative 18. And to cancel out that 1/2, we are going to multiply by 2 over 1. So that gives me x squared equals negative 36. And we take a square root. And that gives me x equals, the square root of 36 is 6, so the square root of negative 36 is 6i. And we want that plus or minus in the front, so that we get both of those answers to the quadratic. So here I have negative 6i and positive 6i. Looking at the next one, I'm not going to show those little algebra steps, but I will talk through them. So here I'm going to move the 10 over, so I get 2x squared equals negative 26 when I add the 10. We're going to divide by 2, which is going to give me x squared equals negative 13. So that's your minimum amount of work if you'd like to skip those steps. From there, we're going to take a square root of both sides. Now I know in class a lot of people write the answer to this one is plus or minus 13i, but 13 isn't a perfect square. So we want to break this up into the square root of negative 1 times the square root of 13. The square root of negative 1 is I, and that I stays after the plus or minus, and the 13 has to stay in the radical. Now I could have skipped this step and gone straight to this answer. That's totally fine, but I want to point out that's how it breaks up. Okay, so my final answers are negative I radical 13 and positive I radical 13. Looking at the next problem, it says which of the following is equivalent to 5i times 6i. So that is 30, and then I times I. Remember, I works like a variable. In most situations, we said it might be a little different with exponents, and we're going to see what happens here. So here, if it was 5x times 6x, I would get 30x squared. 5i times 6i is 30i squared. So what do we do with this I squared? We said it acts like a variable, but once we get to exponents, we have to think a little more about the definition. So I'm just going to rewrite my 30 in the same color. So one way we can think about it is that definition of I. So I is the square root of negative 1. And if I have a square root squared, right, if I do the square root of 3 squared, that radical just cancels. So this is just equal to 30 times negative 1, which is negative 30. So that's one way we can tell that the square root of negative 1, or I squared, square root of negative 1 squared, is negative 1. If I was going to actually write this in expanded form with the squared, that would be 30 times the square root of negative 1 times the square root of negative 1. So once again, we see when I do a square root times itself, right, we just get the number that's inside. So 30 times negative 1 would still be negative 30. So no matter what way you look at it, the square root of negative 1 squared, I squared, is negative 1. So we can have these imaginary numbers, but then sometimes when they have exponents on them, they come back out of the imaginary number system into the real number system. Now, what we're going to do is look for a pattern, or how do these exponents work in general. So the first one, I to the 0, is something we could spend a while talking about it, but basically we're just going to go with the math rule for now. We'll talk about it more in the exponents unit. Anything to the 0 power has to equal just 1. So if you have I to the 0, that's 1. Now, even if we had x to the 0, that would also be 1. Anything to the 0 is 1. Anything to the first power is just itself, so I to the first just has to equal I. Once we get to I squared, right, a couple ways to think about it, but I'm just going to write that means the square root of -1 times the square root of -1. And whenever I have a pair of square roots of -1, those radicals cancel, and that just equals -1. Now we're going to be looking for these pairs as we go along to find the pattern. Now in class I would want you to find this pattern on your own, or at least start to try it, but I will go through all of it. So on each of these problems I'm just basically writing out what they mean. I cubed is 3 square roots of -1. Anytime I have 2 of them, right, just like up here, that equals -1. Anytime I have 1 of them, right, -1 to the, or 1 to the first, I'm sorry, I to the first, that just equals I. So right now I have -1 times I, -1 times I is just -I. So my next one, I'm going to write them in a row. We have 2 pairs of I squared. That should make sense. I squared times I squared is I to the 4th. So that is -1 times -1. -1 times -1 is now +1. Now if you haven't started already, I definitely suggest doing this on your own, because finding the pattern will help you remember it better. So here I have -1, -1, and then I just have 1 left on its own. So -1 times -1 from each of these blue circles, and then the green one is just times I. So -1 times -1 times I, that's going to give me +1, right, times I is just I. So far I have 1, I have I, -1, -I. I have 1, I have I. So we're starting to see a possible pattern. We're going to do the last 2. So if this pattern is emerging, it looks like it's a 4-step pattern, and I have in that 4 steps 1, I, -1, -I, and then it looks like it's repeating. So then I have 1, I, so I'm expecting, if this is the pattern, -1 and then -I. So let's write that out. Pairs. So I have 3 pairs, so that's -1 times -1 times -1. 3 -1s multiplied together is -1, which is, as I said, next thing in the pattern was that -1. So the last one, and there are other ways to think about this. I'll show one on this video after I write this long string. Okay, so we know we have the 3 pairs, and then I have an additional I at the end. So here I have -1, right, from the 3 -1s multiplied together times I. So this one does equal -I. So we're kind of looking for that pattern. We found a pattern. We are now going to look at this sentence at the bottom of the page. It says, we see then from this pattern that every power of I is either -1, +1, I, or -I. And specifically the order that we found falls back on these first 4 answers in this order. So we have 1, I, -1, and -I. Now if I had a higher power of I, I'm not going to sit there and write out, I don't know, 25 square roots of -1 to figure it out. In math, once we have a pattern, we want to find a way to jump 2 answers down that line without figuring out the long way which one is correct. So we're going to look on the next page to come up with that method.